I'd like to introduce René Nuñez Suárez from Turbococina.
My name is René Nuñez Suárez. I come from El Salvador. I'm an engineer. I have been working in the different fields of engineering, in the electrical, electronics, automatic control systems, and advanced combustion. During the last 16 years, I have been doing research and development in a new combustion method. I have a US patent on this, and I have patented the method and the apparatus. Well, after telling you my field of expertise, I would like to tell you the story of Adelina. So I would like to fix your eyes on this picture, and I'm going to tell you that Adelina is a 33-year-old widow who lives in the volcanic countryside of El Salvador. She has to rise before dawn every day to forage for wood, and she has to go for 12 miles every day and come back at home before the daughters have breakfast. She comes back with this bundle of wood, tired and sweating, and she has to cook breakfast for her 3 daughters. Inside this humble home filled with acrid smoke, these 3 girls take their plates of beans, tortillas, and a cup of coffee, and every day is the same story. The young girl coughs and always say the same thing. Mother, you know that smoke makes me cough and gives me headaches. Please stop it. But Adelina just say, one day I will be able to stop it. And she dreams what to do to improve the life of her 3 daughters. So what is the problem? The problem is 3 billion people around the world cook their meals on very inefficient stoves. They use a lot of fuel and produce a lot of smoke. But all these traditional wood stoves are deadly. Traditional stoves are harmful to individuals, to the health of individuals. Every 16 seconds, 1 person dies caused by the inhalation of smoke that is produced by these traditional stoves. That's right. These traditional stoves use long and thick logs of wood, and they are obtained by cutting down trees. So the degradation of the forest, or the destruction of the forest, is always advancing. And this leads to an increased greenhouse gas emissions. Also, it makes a damage to society. In this picture, you can see the smoke inside of the kitchen of Salvadorian schools. Women and children have to inhale that smoke. And also, I would like to point out that it has they use thick logs of wood. So what I propose is an innovative solution. I have called it Turbococina. What does it do? It eliminates harmful emissions by 99%. It eliminates or reduces particulate matter by 99%. It reduces the use of fuel by 96%. It reduces greenhouse gas emissions or carbon dioxide by 95%. I would like to recall that the Kyoto Protocol mandates to reduce carbon dioxide by a meager 5%, and we can reduce it by 95%. I'm not good in mathematics, but you can divide that number and find the ratio. And the thermal efficiency, it's over 93%. Those who are in the technical field know that anything above 70% in thermal efficiency, it's almost impossible to achieve, and classical physics says you cannot do it. But we are over 93% now. So how can we do that? In this picture, I'm showing you a lady putting some wood to a turbococina, and the turbococina uses only small pieces of wood that are easily obtained for trimming or pruning thin branches of trees. And if you can think that it only uses 4% of the wood that any standard traditional stove uses, this is a lot of savings. And also, they don't have to pull down the trees, so the trees remain. And we have made a calculation that for each person that would use a turbococina, you would need just to have one tree for each member of the families. So if we have 3 billion people, we need to have just 3 billion trees and trim those trees and harvest the wood and keep the trees for putting oxygen into the air. But what is new about this technology? It is not only that it uses a minimum amount of fuel and produces the maximum heat, it also is the only technology available in the world that eliminates black carbon. Black carbon is produced by all traditional stoves and by all improved wood stoves. This is the only technology that has eliminated black carbon. And I wanted to show you the image that is on the far left of the picture. That's where I started to adjusting the black carbon elimination capabilities of the Turbococina. And in that image, we have about 1/100th of what a traditional stove produces of black carbon. After I adjusted, the one on the far right is less than 1/100th of the one on the left. And at that time, we were having just 82% in thermal efficiency. Now, I have improved the technology, and in that time, I used to call it the black carbon killing technology. Now, I didn't bring any picture because it's just a blank picture. It's a white paper. And I call it the true black carbon killing technology. And I can tell you, people love it. We have got to 93% thermal efficiency, but we know that by January next year, we will be getting close to 97%. It is possible. Our value proposition is to improve the health of individuals, the environment, and society. Our current business model, we have a private-public partnership with the Ministry of Education of El Salvador and with the existing social aid networks that are poverty alleviation programs, and the distribution of the Turbococinas and the training and the monitoring is financed through carbon credit. It is given to the poorest of the poor and also to public schools. The name of our program is Turbococina Rural Cooking Stove Substitution Program for El Salvador. It's a UN Clean Development Mechanism program. It is the second one of the Clean Development Mechanism programs to be eligible for carbon credits. It is designed to reach 500,000 people in El Salvador and 700,000 school children. Here we have some Turbococina at a school. There's no smoke. They were so happy to have the Turbococinas. My colleague Diego is laughing right there because he's right there in the picture. And so they wanted to take the Turbococinas outside. And it was like a party that day. And I remember that day with such a deep emotion in my heart, because children start to shout, and because they were so happy. What is our project experience? Over 1,000 Turbococinas have been already delivered to public schools, and we're covering close to 150,000 students, and 20,000 mothers have been already trained. Here you can see the Turbococina. It is easy to use. It is adaptable to any cooking practices. It can be easy use. It could be easy adaptable to any culinary practices. She's making tortillas, and they could be doing chapatis in India or whatever. And food tastes a lot much better. So the story of Adelina Erazo has a happy ending. Now she has a Turbococina. That man over there looks like myself. Probably they clone it. It might be me. I don't know. Now she doesn't have to wake up early in the morning before dawn, because she just goes nearby to get the little amounts of wood that she uses for cooking. She does it once a month, sometimes twice a month. Her daughters do not cough anymore, and they're all happy. Her humble home is smoke-free. It is not a health hazard anymore. So I would like to point you out about black carbon. All that blackness that you have seen in the previous slides goes inside the lungs of all these women and children. And it kills them. Now we know that black carbon kills people. Now we know that traditional stoves kill people. What our next steps should be? We would like to scale up El Salvador project. So we're looking for capital for manufacturing, training, and distribution. We would like to replicate this project in other countries and couple it with other technologies. I haven't told you that the Turbococina uses a very small fan that I took it from the electronics industry. I'm an electronics engineer. So I took it from the computer stores and put it into a Turbococina. So there is also place for innovation for the manufacturers of stoves, of fans, to design a fan that is appropriate for a stove. And we could also need some help to to put together this technology with another technologies that are clean and have the Turbococina as a stand-alone system, so it can produce its own electrical energy. Because nowadays we need to connect the Turbococina to an electrical outlet. But we haven't met somebody over there who has the answer, and I'm happy to know it. So we can change the need of wood for cooking and turn it into a solution on using wood in a very efficient way for cooking and also producing electricity. So we could change the scenario of these poor people that have nothing, and to have such an invaluable product that would be useful for cooking their meals, produce enough electricity to light their humble homes, and why not to charge a cellular phone? People need to be connected. That's why cellular phones are so popular. I would like to tell you other stories and think about them. Just by the time that I have been here talking to you, more than 52 people have already died because of the use of these traditional stoves. But also, I would like to ask you to think about past history. During the Second World War, 6 million people died at the Holocaust. And they were killed just because they were Jews. But in the next 11 years, 20 million people are going to die just because they are poor and they are using their traditional stoves. And they use it because they have to survive. It's up to us to change that destiny of those 20 million people. For me, it's my goal. I hope it is your goal. I want to remember also one word, one phrase from a great scientist, Nikola Tesla. He said, "Science is but a perversion by itself, unless it has its ultimate goal, the help for man." Thank you very much indeed. Thank you.
Thank you, René. It's remarkable when you think that one life every 16 seconds perishes because of the smoke resulting from the use of traditional wood stoves. A staggering statistic indeed. On that note, I want to make a quick comment. I think many of us are actually eager to taste the food that's heated someday on your Turbococinas, and many of us are also thankful for you having warmed our hearts with your presentation. The floor is open for questions. Yes, Jigger.
Can you give me a sense, well, first of all, congratulations, amazing proposal, and it sounds like a fantastic technology. What's the price point for your Turbococina compared to what they're currently using?
Yes, I always hear that as the first question. What's the cost? But I always answer this question with another question. What is the cost of a life? Right now, the Turbococina, we have to manufacture it in Spain, and because we're using laser technology for cutting and welding, and the home version runs around 70 to 80 euros. But if we think that it's going to last 25 years, and you divide 80 euros by 25, it's almost nothing, because other stoves last a year or 2 years, but most of them last less than a year. This is a technology that has been really improved the lifespan of the machine. So we're really looking to finance with carbon credits, but the carbon credits market, because of the economic crisis in Europe, have gone so low that we're worried about what are we going to do. And we had just fired some of our employees before we came here, but things are like that. For inventors, things are hard to keep on.
Can I ask just one more follow-up question? Mikhail was talking about people buying firewood for boiling water. Is there a culture of actually buying this wood or charcoal at times as well in El Salvador?
Well, the thing is, poor people use wood because trees don't run. They go and pull down trees and cook their meals. So for us, trees have such a value because it gives oxygen to the air. They're beautiful, and they sink greenhouse gases. But for poor people, they have to survive. And so it's hard to buy wood for cooking. There is also an informal market in every country in the world. But that's a kind of a shaky thing to talk about.
One quick comment, actually. I think you mentioned that there was a study whereby in schools that use this, typically they would use 150 grams of wood per student for the lunch. When they use the Turbococina, that went down to 5 grams.
Yes.
Amazing. Just think about that.
Yes, and now we have gone down to 4 grams. So from 140 grams per day per student, we went to 5 grams per day per student. Now we have done to 4 grams, but we hope to go lower than that.
Diana.
Sorry. So to follow up on Jigger's question, I think probably it's going to come up in your impact sessions, but rather than depending on the carbon markets as the mechanism, you probably are going to have to think through some kind of a microfinancing product or some kind of like a pay-as-you-go or pay it down as you use it. If you're talking about something that people are going to use for 25 years. So I guess is that so maybe the question is to compare what people are paying for stoves that they are using that only lasts the year or the 2 years, what are they actually paying for that, so that that can help us think through sort of the alternative business model when we meet with you in the impact session?
Yes, the thing is, they sell these stoves for around $10. So my idea is, and Diego's idea also is, if that Turbococina lasts 20 or 25 years, and we divide, say, $100 between 20 years, it's $5 a year, okay? $5 a year, and we divide it by 10 months, it's just a few pennies. So if the World Bank or this development bank could give the money and being paid back somehow, like the Grameen Bank, because these people don't have $1 to pay, but they have a few cents to pay every week or so. But the thing is, whenever you take money from poor people, you take their meals from their hands.
I think your point's excellent, though, that one of the challenges we have with the impact rotations is how to finance this. Comment.
Yeah, I just want to make another comment, and I'm sorry to interrupt the flow, but from just a launch perspective on this one, we were inundated with cook stove projects as innovations. It was slightly horrifying for us. Hundreds, literally hundreds of applications came through. To the point where the good folk at USAID and at the State Department literally just had to get a group of experts on it to assess which is the best cook stove in the world. So you're looking at it, guys. This is really an incredible technology. I just want to sort of make that point. And then in terms of the launch objective for this cook stove, and maybe just to sort of short circuit some of the questions, how do we get it to $20? How do we get the manufacturing process working more efficiently? How do we get the distribution process working globally? And how do we get the model to work? And really the challenge for this group here is, let's get this all over the world. This would be an incredible thing to do.
Mark.
Well, you stole part of my question, but how much power does it take?
14 watts is the power of the fan, but when using it, it takes less than 12 watts.
So you need to jumpstart the fan, but then...
Yes. I know that there is a DC fan on the market from the same manufacturer, and it takes only 7 watts. But to go from 7 watts to, say, 4 watts, that's an engineering problem. That's not a difficult problem to solve. I would like to point you out, after I have answered this question to you, this is the best wood stove in the world, the most efficient in the world. And we are not talking about other stoves if we compare it. I would like to compare it with on what the Department of Energy set as a benchmark. I was there in January this year, and they said, we would like to have a stove that at least has a 50% thermal efficiency and reduces greenhouse gases by at least 90%. It were no wood stove in the world that came close to this. Only the Philips was close with 45% thermal efficiency. We are over 93% thermal efficiency. That's the double. And greenhouse gases, 99%. That's more, 2 times more.
It is remarkable. David, and then Mikhail, please.
2 quick ones. How long have you been running? Do you have one that's been running continuously for a year, 2 years, 3 years?
Well, I have stoves that have been running for 10 years.
Have you identified the failure mechanism? Everything has a failure mechanism.
Well, those that I gave at the beginning were built of standard carbon steel, and the interior of the combustion chamber have deteriorated very much. Now that I'm using stainless steel, I have Turbococinas that have been using 5 years already, and no failures.
So it's a materials degradation.
Yes, we solve the problem of how to minimize corrosion.
Mikhail.
The data you were displaying on mortality related to cook stoves, 1.9 million per year, that I think is the data set for respiratory infection from the 2009 World Health Report. To suggest that that's all related to indoor air pollution is quite a strong assumption, especially given that about a third of that can be prevented through improved sanitation. So have you done actual health impact studies to see the impact of your cook stove? And to the question, or to the comment from Jeff, I think that, yes, it is a very, very crowded space and one to pay attention to. I think there are two things to pay attention to. One is the most promising technology, but another thing is what has the strongest data set. And I think that we need to pay attention to that.
Well, we know that some U.S. scientists are doing this research. Kirk Smith is using our Turbococinas, and he's testing it. He's from Berkeley University. And he said in a conference at Berkeley University that before they thought that advanced combustion wood stoves were going to solve the problem of health, but now knowing the Turbococinas, he said, we will see history talking about before the Turbococinas and after the Turbococinas. He said that. I didn't say that.
Your point's well taken, though, that part of the reason why we actually need to solve the finance problem to bring down the price point is to establish studies that further give data that can then...
I'm really looking to see, is there anything beyond anecdotal evidence?
Well, the tests were done, all these tests were done, or research were done from people from Berkeley University. They're experts, and all this information was done at laboratory tests at Berkeley, and also some people from the National University of Mexico that did all the tests on the use of the Turbococinas.
The aggregation of data to as a next step is critical, and a point well taken. Thank you so much, René.
Thank you very much.